This is our main tool. It's a hyperspectral sensor, and this sensor captures light reflected by vegetation, and dependent on plant condition, plant species and so on, this sensor captures these differences, and this we can use subsequently in order to derive other products in our computer models. What are we interested in to explore the effects of global change and climate change on vegetation, and what we are doing with remote sensing using our sensors, for example built into an aeroplane, but also sensors in satellites, is to monitor these changes. For example, map vegetation length, which might change due to increasing temperatures. Map, for example, in detail land use. So, for example, we can discriminate different crop types, winter rye, raps, maize fields. What's special about work is that we can follow a certain topic over a fairly long time period. So we can build on long observation series and really see whether you can see trends. But we can also integrate different scales of observations. So we can look at point scales and really try to follow physical processes at this scale, but we can also look at regional and global patterns. What we have been producing over the last years is, for example, a product on plant phenology. So that's, if you like, the breathing of nature driven by the season over time. So green up and plant senescence in autumn, giving the vegetation length. At the moment, driving us is to explore the effects of the recent droughts in forest predominantly, but also in agriculture. In agriculture is a bit less challenging because the effect of a drought is immediate there. In forest is a bit more complex. You have certain lag effects, so sometimes the effects of a drought occur just 1 or 2 years later. And to map these effects and to quantify them is also one main part of a project we're currently pursuing.